Hello everyone, I'm Paul and today we're solving problem 2294, partition array such that the maximum difference is k. This is medium and this one is all about observation. So here we'll go through the intuition, approach and efficient solution. We're given an integer array nums and an integer k. Now we can partition nums into one or more subsequences, and our job is to return the minimum number of subsequences needed such that the difference between the minimum and maximum values in each subsequence is at most k. For example, let's say we have this. Let's say this is nums and this is k. In case you know what a subsequence is, this could be a subsequence. If we remove this could also be a subsequence. If we remove this could also be a subsequence, and so on. For example, if you only have a 3 here, this is a valid subsequence. So we can get a subsequence from this by deleting some or no elements from this. Here we can take 3, 1 and 2 and put this into one subsequence. So we have 3, 1 and 2 in one subsequence. And then we can put 6 and 5 in another subsequence. And now we can get the difference between the maximum and minimum elements in each of these subsequences. For example, here the maximum element is 3. The minimum element is 1. The difference between these two is 2. And 2 equals k. So we are good to go. And here the difference between the maximum and the minimum elements is 1, and 1 is smaller than k, and we need the difference to be at most k, so we are also good to go. And given that here we have 2 subsequences and we need to return the minimum number of subsequences to meet this requirement, we can return 2. Now I told you this is all about observation, so let's see what's happening here. Let's say we take 3, 6 and 2 as one subsequence. And in subsequences we do care about the order of elements. Okay, we care about this order. But given that we are trying to work with only the maximum and minimum values, in this case we are working with 6 and 2 only, actually we could have this in sorted order. So we could have 2, 3, 6 and only check for the first and last elements. And by doing this we reduce a lot of time complexity, because we don't need to look into this entire thing for the minimum and maximum value. We just take the first value here and the last value, and that's it. So as our first step we can sort this. And now that we have this in sorted order, the question is, how do we get the minimum number of subsequences? Or where should we make each cut? For example, should we take this as a subsequence and this as the other subsequence? Or maybe we should take this and this? Because we already know that we can't take this, because 6 minus 1, meaning the difference between the maximum and minimum here, is 5. And 5 is greater than 2, so we can't pick only one subsequence. We need to make a cut here. So our strategy will be to keep track of the first element, in this case 1. We will store this in a variable. We'll call this s. This is initially 1. And then we'll iterate this from left to right from index 1. And every time we will get the difference between the current element and the start, and we will check if we exceed k or not. So right now we are here and we are working with 2. The difference between 2 and 1 is 1. 1 is smaller than k, so we are good to go. We could take this as a subsequence. But remember, we are trying to get the minimum number of subsequences. So maybe we need to update I and check if we can take this one instead. because we want the minimum number of subsequences. So we update I, and now the difference between 3 and 1 is 2, and 2 equals k. So we are also good to go. We know that we can take this as a subsequence. So we update I again. Now I is here, and the difference between 5 and 1 is 4. And 4 is greater than 2. So we can't take this as a subsequence. And this is where we found our limit. We know we can't take this one, but we know that we can take this one. And this happens to be the maximum subsequence that we can take up to this point. So this is where we take this, we add 1 to the result, and now the start is here. So we replace this 1 with a 5, and we update I. Now I is here, and the difference between 6 and 5 is 1, and 1 is smaller than k. K is 2, so we are good to go here. This means we can take this subsequence. And here we reach the end, so we can add this subsequence to the result, which is now 2. And this is what we return. Now we'll do this in a slightly different way. The result will be 1 initially, because we can return 1 subsequence as a minimum. If the difference between this and this is smaller or equal to k, we can return 1 subsequence. So we start with a 1 here, and next we'll follow the same process. We start with the I pointer here, we iterate this from left to right, and whenever we find a limit, we take the last valid subsequence, the greatest subsequence up to the limit, and we add that subsequence to the result. So this will be 2, and by the time the I pointer reaches the end of this loop, we return the result, which in this case is 2. So this is it for the intuition and the approach. We are basically sorting this, and then we are iterating this from left to right, and whenever we exceed the maximum difference, meaning k, between the maximum and the minimum element, we add 1 to the result, and finally we return this. Time complexity for this will be big O of n log n, because we need to sort this, and space complexity in Python will be big O of n, because this is the required complexity to sort in Python. So now let's go with the code, and hopefully you will get the idea. First we need to sort the array, so nums.sort. The result is initially 1, because we can always return 1 as a minimum, and we return the result. And here in between, start will be initially nums at 0, and now for I in range length nums from 1 up to length nums, if nums at I minus start is greater than k, result plus equal 1, and start equals nums at I. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.